So we'll go over all this stuff over here at 10. Talk about bonus problems at 10. Okay, you're going to ask whatever question after we do this problem, whatever you want to see. This is your time. Also at 10 o'clock, we'll go and I'll show you head to head on the review sheet compared to how many you'll see on the test, how many and what kind. You know, breakdown. Okay. This is like number 11 and number 12 on the review sheet. I'll tell you right now. Of all the different versions of the test, you're either going to have this picture that you're looking at right now, or basically it's a lot like this picture, but it's going to be virtually 1, 2, 3 segments, and that's got 1, 2, 3 segments. So if I have to move 3 segments, I got 1, 2, 3, 4 ordered pairs, 1, 2, 3, 4 ordered pairs. I got to figure out where they go. So it's just like the review sheet. You're either going to do something that looks like number 11, you can do something like number 12. Now, on both of these examples and the one we're going to do right now, I'm giving you 3 changes. I put a negative in front of each one. So there's a flip. Then there's something inside the function with x, so there's a horizontal shift. And then there's a k afterwards, so there's the vertical shift. So there's 3 different transformations. On your test, I'm just going to have you do 2. So maybe you'll have a negative and a horizontal shift. Or maybe you'll have a negative, and this will just be an f of x, nothing inside. So a negative, you're going to flip it, and then you're going to shift it up or down. Or maybe you won't have the negative, and you'll just have a horizontal shift and a vertical shift. So you're not going to have to do 3 things, just 2 things. Okay? Bottom line is this. You need your pairs. What I'm going to do is I'm going to make a list of these order pairs. So over here, from left to right, go in order, you have on x and f of x. -4, -4. -1, +2. 4, 2. I am going to move this just a little bit. I'm going to actually make it a little bit bigger, but a little wider space to work with. OCD. X and my y values f of x. -4, negative. -1, 2. -14. 8, negative. And then over there, remember we're trying to figure out this picture. Trying to figure out, we got y equals a times f of x minus an h, and then you have a plus k. So you want to identify what does a equal, what is H equal and what is K equal? So what's the A, if there is one, what's the A that would be in front of the function? A -1. And what that's going to tell you is it's going to flip. It's going to reflect across the x-axis. And the way you do that is you change the sign of the y coordinate. You're going to multiply the y value by -1. This -4 would get multiplied by a -1 and would flip up to +4. +2 gets multiplied by a -1, flips down to -2. That's how it reflects across the x-axis. You multiply the value of the function times -1. H has to be inside the parentheses with the x. Has to be with the x, and it would have to be in the parentheses with the x, or inside absolute value with the x, or inside the square root with x. If I see square root x and then +2, that's not H. It's after the square root. It's not inside the function. It's after the function. So that's a K, not an H. So in here, there is something in there. Remember, the negative is already there. It's already built in. So when you take out the 8, the horizontal shift, you're going to take out the opposite sign. So what's H? +2.
We don't take the same symbol, like the negative.
You take out the opposite sign. Because the negative is already there. This negative is part of the formula. So what would H have to actually equal if I end up with x -2? I would have to subtract the +2. Because if H was a -2, if it was x minus and H was a -2, x minus H and H is a -2, then I end up with x +2 on the inside. Okay. So H is -2. Sorry, get away. It's a +2. Positive. That means the graph is going to go left or right. It's going to go to the right. H is a +2. So the horizontal shift is going to go to the right. Now, here's what I want you to do. Forget about this x -2 for right now. Just forget about it. Don't even think about it. As soon as you know what H is, look at the picture. If it's going to go 2 to the right, then this -4 is going to have to go over to -2. This x is -1. It's going to have to go 1 to the right. It's going to have to go over here to +1. This x is a 4. It's going to have to shift over to 6. This x is an 8. It's going to have to shift over to 10. It's going to go 2 to the right. Okay? But if you stare at that x -2 in there, you're going to want to go this other way. That's why you take the h out and then think it through. You know you're going to go to the right, because h is positive. And then k is what? -3. There's a plus in front of k, so you're going to keep the sign. You would have to add, k would have to be a -3, plus a -3 ends up being -3. So k is -3. So that means all of the y values, once you reflect it, you're going to shift it down 3. First thing that you do, find the x coordinates for g of x. Find the x coordinates for g of x. This x is -4. Look at the picture. You know it's going to go 2 to the right. So if it's at -4 and we go 2 to the right, what will the x be over here? -2. It's going to be -4, and you're going to add 2 because it's going to go 2 to the right. So this is going to be at -2. She gets h is +2. That's why I don't want you to look at the numerator. I want you to look at x minus 2. And then this -1 has to end up at +1. You have to go 2 to the right. -1 plus 2 is +1. That's that you export. And again, I'm just doing the x's. One piece of the puzzle. I need ordered pairs. I need the x's. I'm adding 2 to all the old x's. That way, everything is going to shift to the right 2 units. This 4 has got to go 2 to the right. So you're going to take this 4. To go 2 to the right, you add 2. We're at 6 in. And we'll take this 8. We add 2 to push it to the right. So this 4 for x is a 10. Those are the x coordinates for the new graph. And I don't need to worry about those anymore. Forget about those. Because you're not plugging in anything. You're now going to do the y values. So what's going to happen to y? Once you plug in x, you're going to do the opposite sign of the old y. You're going to multiply by -1, and then you subtract 3. So watch the transformation. It's negative f of x minus 2, and then you take away 3. So this -4 times -1 would flip up here to +4. It would flip up to +4. Okay. And then you have to subtract 3 from it. And if I subtract 3 from it, it's going to push it down, shift it down to 1. Now, granted, it's also going to be shifted, but right now, let's just say there's no 8. There's no 8. If this was all it was, opposite of f of x, and then subtract 3. So I multiply by -1, this becomes +4, and then you subtract 3, which is going to move it from here down to here. You're at -4 and +1. Change the sign because of the negative, and then subtract 3. So you're going to take this -4. You have to multiply by -1. And then we're going to subtract 3. So that's -4 minus 3, and we get -7. My bad. The old y was a what? Yeah. See? This is what happens when you're like, do you guys ever, like, you're doing a test, you're writing like this, and you don't see the big picture because you're too close to the paper? Every now and then you have to like back up and take a look. I'm going, that doesn't look right. Yeah, it's -4, so it should have been this -4 times that -1, so +4, and we take away 3, and it's a 1. Because that's what I told you it was going to be. That's why I knew there was something weird going on. Okay. And then this multiplies to 2. So we take this +2. We have to multiply by a, which is -1. And then you subtract 3. So -2 minus 3, this is going to be -5. This one is going this way, 2 units. It flips up to 4, and then it shifts down to a 1. -2, 1. You have to label. You have to label the order pairing. You plot the point and you label the order pairing. -2, +1. Then the next one, you got 1, -5. This point went 2 to the right, so we're at +1. And then this got flipped. So +2 flipped down to -2. So it flipped down to here. And then we subtracted 3 more and it moved down to here, -5. So it shifted to +1, flipped upside down, and then subtract 3. So it's right here at 1, -5. Label 1, -5. And keep going. Multiplied by -1, 2 times -1. And then we subtract the 3. -2 minus 3, -5. So that's 6, -5. Don't forget to label. And this -4 times the -1, take away 3. That's +4 minus 3, so this is +1. Yeah. So we're at 10-1. On your test, pencil only, please use a straight edge. That is the straight lines. Now, we're not stretching it at all. We're not stretching it left or horizontally. We're not stretching it vertically. So it should be exactly the same shape as this original, just shifted left or right, shifted up or down, or maybe flipped. Now, here's a good way you can check to see if you did this correctly. Do you see how these 2 points are even with each other? -4, -4. Then these 2 should be even with each other. Straight across.
On the second pairs, you did 2 times -1. Yeah, so isn't you did -2 minus 5?
Oh, that's my mistake.
Oh,
I got -5.
okay.
So I wrote that -3.
Yeah, this is confusing already. Because I thought the 3 was a 5.
Well, it's 6 for 9. That's what Jimi Hendrix. You know Jimi Hendrix is? Or what? You don't know Jimi Hendrix. Are you?
I think I'm a little confused on the negative f(x). So the a of the -1, yes, the negative sign, and then the f of x. So you wouldn't solve the f of x first, so like plugging in the original x.
We're not plugging anything in, number 1.
Okay.
Well, watch this. I'm going to plug in -2. So G of -2 would equal negative f of -2 minus 2. And then we take away 3. Okay? Substitution. All I did was plug in -2 brackets. So in here, this G of -2 would equal negative f of -4. And then you take away 3. So G of -2 is equal to negative f of -4. When I plug -4 into f, we get -4. And then subtract 3. So that's +4 minus 3, we have 1. Which is just this right here. times -1, and then subtract 3.
So no, that explains it.
So yeah, so we're doing the transformations, we're doing the x's. What's happening to x? It's a horizontal shift 2 to the right. So I took all these x's, -4, -1, 4, and 8. Everybody's going to take 2 to the right. So that -4 add 2, -1 plus 2, 4 plus 2, 8. Just handling the x's. Then what happens to the y? What happens to the y's is you're going to change the sign of the old y. And negative is going to flip. So that becomes +4, and then you subtract 3 from it.
So after you do your x's and you're onto your y, so that you're just your negative, this is messing with my brain. So like the negative f of x right here. Once that's done, I think I'm confused to like I guess the relationship between the a and the f. So f of x is 1, 2. It's not a, f, and then x. I think I keep breaking it.
Right. So this is the y values.
Okay, yeah.
So it's the opposite of the old y values. It's the opposite of that. So maybe I should write it as this -1, and then times the y value, which was -4, and then we take away 3. A times what's the y value? Let me plug in that number,
Okay.
and then we take away 3. So this one would have been -1. This y value is a 2, and then we take away 3.
So you ignore that minus 2 cents.
Well, because I've already done it.
Yeah, okay, I can.
And so, yeah, exactly. It's a horizontal shift. I already took care of the 2.
Okay.
I don't ever want to go back there. I don't even want to look at the x minus 2. Once I figure out that h was +2, I don't even think about this anymore. I'm going to just go, all right, 2 to the right, we add 2. Not even going to worry about x minus 2 ever again. 2 to the right. But it's added 2 to the x.
So it's just f of x is 2, then definitely +2.
Well, h is 2. H is
H is
positive.
2, yeah.
H, yes. So all the x's 2 to the right, add 2 to them.
Okay, so stop double solving equations. Got it.
Right, we're not actually going to plug it in, we're just moving it.
Yeah.
So the horizontal shift is 2 to the right. What's happening to the y's? You're flipping it, and then you take away 3. So you change the sign, and then you subtract 3. Okay?
Got it. Thank you.
So now, here's how you have a good idea that you did it right. As I'm saying, these two should be even with each other. Those two down here, they're even with each other. Another good way. From -4, right here, how far is it to 8? How far is that? 12. It's 12. This is 12. So here we're at -2. How far is it to 10? 12. They should be the same distance apart. These two, this is at -1 and that's at 4. How far is it from -1 to that 4? How far? 5. So here you're at 1 and that's 6. How far is it from 1 to a 6? 5. The length of that one is 5. So that's a way mentally you're looking at your picture. It should be exactly the same size, shape. It's just flipped, shifted to the right, and shifted down. Okay. I've seen this one done, and I've seen pictures that they end up with a point there, they got a point here, they got a point there, and they got a point there, and they're making some kind of weird thing over. No. It should be exactly the same looking picture. Which means if that's the case, and I'm telling you, it should be the exact same type of picture, why would you draw something better? Well, first of all, this has 3 segments. Why would you draw something with 4 segments? Where the extra segment? But the whole purpose of it is to understand how the graph is transformed. To understand what A does, what H does, what K does. Not to guess, not to hope. We don't hope it. We don't guess it. The goal is to understand. Okay. So you tell me what you want to see. These are the ones that we've already done. In red are the ones we want to edit out. You don't need to worry about turning those in. So, be specific. So if it's from a homework session, tell me which section, which problem. If it's from the review. If it's from the review, just tell me a number. But if it's from a homework session, please tell me the homework. Yeah.
1.3, number 85.
1, 3, number 85. Now, if you notice, there isn't anything on the review sheet like number 85, but when we did 1.3's homework, I told you of a bonus. F of x is x squared minus x plus 1. And we're supposed to do the difference quotient, simplify, substitute and simplify f of 2 plus h minus f of 2 and all over h. H cannot equal 0. Okay. Little restriction, h better not equal 0, because if it does equal 0, we get indeterminate. Three things I'm going to be looking for when we're dealing with functions. When we do the operations with functions, addition, subtraction, multiplication, division, composition of functions, the first thing I got to see, and this is what I put on the board on Tuesday, you got to show me the rewrite. Example, you have f plus g of an 8. Then I want to see the rewrite. What is f of 8 plus the g of 8? Okay, you had something like what is j times f of -3, then I want to see the rewrite. That's j of -3 times f of -3. If you had something like, let's go with p times q of x. I want to see the rewrite. That's p of x times q of x. If you have a composite function, if we had h circle f H circle f of 2x, then I would want to see that's equal to h of, and then inside that is f of a 2x. I want to see the rewrite before you do the problem. Rewrite. And then step 2, you substitute. And then step 3, you simplify. I'll show you work. And you repeat if necessary. So here, it's not operations with functions. It's not, you're not doing addition, you don't only have one function. So we just substitute. So we're going to replace x with the 2 plus h. So all the x's get replaced with a 2 plus h. Use parentheses, make sure you do it correctly. And it's the numerator. 2 plus h is going to get squared. And then minus this x of parentheses is a 2 plus h. And then you have a plus 1. Now, because it's the first term, and it's just this, it doesn't hurt if you don't put it in parentheses. You're not going to get it wrong if you don't. I'm going to. Because it's this f of 2 plus h, this thing, and then you're going to subtract the f of 2. What will hurt is if you don't put the other one in parentheses, because you're going to subtract that. So that's where it matters. So here's my f of 2 plus h minus my f of 2. So we're going to plug in 2 now. And we get 2 squared minus 2 plus 1. So inside here, we got 2 squared minus 2 and plus 1. I want to see the substitution. I don't care what you can do in head, I want to see the substitution. And don't forget, it's a fraction, the denominator is h. That's just the substitution. Show the substitution. Now you're on your way to getting, the correct answer, because the rest of it is just arithmetic. Arithmetic and a little bit of algebra. Good idea is to make sure you always remember the denominator. I've seen this one, people keep working, but they don't bring the denominator down apart. In here, 2 plus h squared is 4 plus 4h plus h squared. Minus 2 plus h, so you distribute the negative. So it's minus 2 minus h. And then we have a plus 1. And minus. This is, and you can do this up here, 2 squared, that's 4. 4 minus 2 plus 1. What's 4 minus 2 plus 1? 3. So in this parentheses, it's a 3. So it's going to be a minus 3. So I multiply 2 plus h squared, that's right here. Distribute the negative, negative 2 and a minus h and a plus 1. Now I'm going to simplify the numerator. Starting with the biggest power, the greatest power for h is this h squared. So you're going first, h squared. Then I'm looking for h to the first. There's a positive 4h and a negative 1h. 4h minus 1h means 3h. And then my constant, that's all I have left, is a positive 4. 4 minus 2 is 2. 2 plus 1 is 3, and 3 minus 3 is 0. So there's no constant. That's all you have, all of range. Now you just have to reduce that. When you have something like this, we're going to see this quite a bit. There's only two acceptable ways for you to show me how to reduce this. This would be unacceptable. If you do this, and you just say, all right, the answer is h plus 3, and you don't show me how you get out that, you're not going to get full credit. How'd you get that? If you do this, you're not going to get full credit. The only way you can reduce fractions is by factoring. You have to factor before you can reduce. So we have two terms, they each have an h and an h down here. So there's a common factor of h in all of these terms. So you have to factor out h. When you factor it out, you're dividing each one of these by h. H squared divided by h leaves h to the first. Plus 3h divided by h is just 3 all over this h. Now you can reduce because it's multiplication. Final answer is h plus 3. You have to factor it, show me the factoring. Or you can do the splits. Because the denominator is a single term, I can split this into separate fractions. I can split this into h squared over h plus 3h over h. And the reason why, when you add brackets, when you have a over c with a common denominator, plus or minus b over c, doesn't matter whether you add or subtract. Then you add or subtract the numerator. Let me do this over here so I can go left to right. If I have a over c plus or minus a fraction b over c, then you just add or subtract the numerators over that single c. Okay, that's how we add fractions or subtract. Well, equals works both directions. If I have two fractions with the same denominator, this is how you add or subtract them. So if I have something that's a single fraction like this with addition and subtraction between, I can separate it into individual fractions. I can go that way. So I can split this up, h squared over that h, and then 3h over this h. Now, oh yeah, rules of exponents. You subtract the exponents, that goes in, leaving h to the first, plus that just reduces me to 3. So you either show me the splits or you show me the factor before you reduce. And that's going to be an issue that some of you are going to have to figure out the whole semester. Keep on going. Some of you just don't want to cross things off, and it's just not going to work. Not going to work. So bonus like that. Yeah.
Last bit real quick, I'm a little confused on how you were able to reduce the h over h squared by taking away the factors.
So h squared over h is equal to h times h over an h.
Oh, okay.
But it's also, when you have a to the m over a to the n, it's a to the m minus n. You subtract the exponents. So h squared over h This is a 1. So it's h to the 2 minus 1, which is h to the first, which is just h. What else?
Did you do number 24 from the review?
24. Because there's so many and not a lot of time, can you pick one in particular with this one? Midway. 24. Three steps. You got to show me one, the rewrite, then the substitution, and then the simplify. When you're dealing with pictures, it's just the order pairs. (24a). We want F circle G of -5. So the rewrite, that means we want F of G of -5. That's the rewrite. We have to find the inner function first. To figure this out, we have to figure out G, this part, the G of -5. So we go looking over here at the graph of G, and when you plug in -5, the y value is equal to -4. That's the order pair when you plug in -5 for x. So you're looking for the x coordinate on the G picture, where x is -5, and the y value there is -4. So this right here is now a -4, because that's what G of -5 equals. So it's now f of -4. So now we go looking at the picture of the f function, and when we plug in -4, the y value is 4. That's circle G of -5. Unraveling the pieces.
40.
For E.
Question with that, I'm so sorry. I'm just like kind of lost, like, did you just like plug in order pairs?
Yes.
Okay, and just plug it in.
Yeah, you have to rewrite it first to know what you're actually looking for. F inverse, what we did on Tuesday, circle F inverse, circle G inverse is 3. So first thing is the rewrite. So that would be F inverse of G inverse of 3. So you start on the inside, let's start with G inverse. Then find G inverse of 3. Now remember, we don't have a picture of G inverse. Got a picture of G. The inverse ordered pairs, though. The inverse function and the function have ordered pairs that are switched. So X and Y on the function is switched YX on the inverse function. So this is what I want to plug into the inverse function. I want to plug in 3. That means on G of X, this 3 is the Y value. It's the Y value. So I got to go over here and find on G where the Y value is a 3. So when does Y equal 3? When you plug in 2. So what is G inverse of 3? It's a 2. And now I know I'm going to plug this to it. And since I'm plugging 2 into the inverse function, I want to plug 2 into the inverse function. I don't have a picture of F inverse, I got a picture of F. If this is the inverse function X, then on F of X, that's the Y value. Inverse functions and functions switch the ordered pairs. So the function's X is the inverse of Y and vice versa. So this 2 that's going into the inverse is the Y value on F of X. So when do we get 2? We get 2 right there when we plug in 0. Oops. 0, 2. When 0 goes in, we get 2. So F inverse of 2 is 0. So this equals 0. It's all about rewriting it. And I made this so you can put in your own order of pairs, finding it a little easier. All right, going back at 10. Wow, nobody checked by the fuzzies.